yet another episode where we shall be looking at the November 2024 paper 1 for physical sciences, grade 11. Okay. So this is just a suggested memorandum of the paper that one of the districts wrote. Okay. So we have how many questions? We have 10 questions. We must answer all of them and all the other instructions. So question 1, which is the multiple choice, they're telling us that which one of the following forces always acts perpendicular to the surface? Normal force, that is true. Frictional force, no. Gravitational, this acts downwards, and then tension, it's not always. So always will be the normal force, which is A. Then 1.2, when a spaceship moves at a constant velocity, it means that the resultant force acting on the body is a 0, which is true. Which phenomenon is this? This should be Newton's law 1. Okay. So option A will be the correct one. Then a sphere is attached to a string, okay, which is suspended from a fixed horizontal bar, as shown below. Now we're seeing that the reaction force on the weight of the sphere is described by Newton's third law. So which means the tension force within that will be the reaction of the weight downwards. All right, so they're asking us the reaction force that we need is the force of the bar on the sphere. The weight or the force of the string on the sphere, the force of the sphere on the earth, and then the force of the bar on the string. So the easiest, since we're looking at weight, which is the sphere acting on the earth, which means the earth must also react. So I'll go with option C. Okay, then 1.4, there's a force F that is applied on a block, and then the block moves on a rough horizontal surface to the left, as indicated using constant acceleration. So which of the following relationships between the magnitudes of X, Y, and Z will be true? So initially we know that X and Z must be equal. So we're looking at option C and D, because that's where we have X and Z being equal. But then they're telling us that F is equal to Y. So for F to be equivalent to Y, this object shouldn't be moving. Okay. But then they're telling us the block moves. So this one is out. I'll go with option D, just using the elimination approach. Then 1.5, they're telling us the net force which acts on a body of mass M causes an acceleration E. If the same force is applied on a body of mass for M, what will happen to the acceleration? So we know that force is equal to ma. Okay, F net is equal to ma, which means the question is asking for acceleration. So acceleration is indirectly proportional to the mass, or inversely proportional to the mass. Okay. Now, initially, this is going to be our acceleration. Now, if the mass is changed to 4m, which is going to be over 4m. Now, we know that initially this was the F over m, which was the initial acceleration. But now we have something extra, which is the 1 over 4. So which means we're going to have B as the correct option there. 1.6. If object X exerts a gravitational force F on object Y when the distance between the centers is R, the distance is now halved. Which of the following represents the force? Now we know that the force is inversely proportional to the square of the distance. Okay. Now, if we're looking at 1 over 0.5 squared, okay, when you simplify that, that's going to give us 4. 1 over r squared. So which means the force is going to be 4 times bigger. So as you decrease the distance, the force will increase. And 1.7, two small identical spheres, each carrying this charge, are brought into contact and then separated, the charge on each. So when spheres are brought into contact, for us to get the charge on each, we must add up the charges and then divide by 2. So 2q over 2, which means we shall have q, which is option C. 1.8, a small negative point charge is situated halfway between two identical spheres, P and Q, carrying identical charges, as shown in the diagram. So sphere P exerts electrostatic force of F on Q. What is the magnitude of the net electrostatic force experienced by the point charge? So since Q is halfway between the net electrostatic force, remember these are identical. So if they are identical, which means there's going to be repulsion between them, not attraction. Okay. So the net force will be 0. Net force will be 0. Then 1.9, if we have a circular coil that is placed inside a magnetic field and rotated clockwise to induce an EMF, which of the following changes will increase the EMF? So we know that induced EMF is directly proportional to N change in flux, then over the area. No, it's over the time. And then the flux will be the B area and so on and so forth. So we need to rotate the coil slower. Nope. You need to increase the number of turns. That's correct. Decrease the strength. No. Change the polarity. No. So B would be the best option in that case. 1.10. 3 identical bulbs X, Y, Z are connected in a circuit diagram as shown below. The internal resistance is ignored. When the switch is closed, the reading on the ammeter A1 is 2.5 amps. Okay, so this 2.5 represents the total current that is passing through the circuit. And then the 2.5 will be split up, okay? So a half of 2.5 will be 1.25 amps. So which means Y is going to be 1.25, even this one is going to be 1.25. Which of the following options correctly describes the readings on the ammeters if Z burns out? Now, if it happens that Z burns out, okay, Z is gone. All the current is now going to be channeled through this X and then the Y. And since X and Y are going to be in series, the current is going to stay the same. So we expect a 2.5 by this ammeter reading, which is the total current. And then we also expect a 2.5 by the ammeter reading A2, and then 0 current there. So 0 current, we have those 3 options. Do we have a 2.5 for A1? It's there. But then it's 1.25 here, which is wrong. 3.2, 3.2, 1.8, 1.8. What's happening? What is happening? So I'm not seeing any correct option here, because it cannot be 1.2. Nope. It cannot be that. So in this case, none of the above. I don't see any correct option because I expect the current to be the same within the series. Okay. So then that would have been question 1. Then question 2. They're telling us that a heavy object is lifted using 2 ropes and 2 pulleys, as shown in the diagram below. The 2 pulleys are a distance x apart, and then the force Fa in the rope A is 730, and then the force B is that. Rope A makes 70 degrees with the horizontal, while B makes this with a vertical. Define the term resultant vector. So we know that resultant vector is basically a single vector. Okay, single vector that will represent the combined effect of two or more vectors. Single vector that represents the combined effect of two or more vectors. Okay, that's a resultant vector. Or it's a single vector that will have the same effect as combination of two or more. Then explain why the vector diagram of FA and FB, as well as the way it will not be closed. So we know that for a vector diagram to be closed, the forces have to be in equilibrium, or the net force has to be a zero. So we can say that the forces are not in equilibrium. The forces will not be in equilibrium. And then 2.3.1, they want us to get the vertical components. So we resolve this into the horizontal and then the vertical. Remember, it's head to tail. So this vertical here, since it's just opposite, which means it's going to be FA, the sine of 70. But we already know that our FA is 730, so it's 730, the sine of 70. If I punch that into my calculator, I'm getting 685.98. 685.98 newtons. Then 2.3.2, they want us to get the maximum weight that F and FB will be able to lift. So what we can see is that for us to get that answer, they're indirectly asking for the weight of the object. Okay. Now looking at the direction of the forces, with the weight is going to act downwards, but then we're going to have a component, vertical component of B, and then the vertical component of A. So if we add those two, can as well get the A. So I'll come down and say that my F vertical of B, okay, since now this is that's going to be FB cos of 10, because the adjacent. So 1440 cos of 10. 1440 cos of 10, I'm getting 1418.12 newtons. Okay. F vertical of B, we got 685.98, which means FVA plus FVB will be the 685.98 plus the 1418.12. When I add those two, I'm getting 2104.10 newtons. So that's the weight that the two pulleys or the two ropes will be able to lift. Then 2.4, explain why the rope and the pulley system will be less effective if the distance increases. So what is going to happen is that there's going to be loss of mechanical advantage, because these pulleys are meant to make the lifting of the block much more easier. But now, if you increase the distance, it will be like you're lifting a block using ropes by the sides, which is a bit harder, okay, compared to if the ropes were in this sort of direction. So what we're going to say is that the mechanical advantage decreases, okay, because increasing X is going to reduce the vertical component. It reduces the vertical component or components of FA and FB. Okay, so if the vertical components are reduced, which means the system will require a lot of force to lift that object. Okay, so guys, that is question number 2. Then question number 3, a man faces difficulty while swimming in a dam. So during the rescue operation, there is an inflated tube that is attached to the helicopter by a rope and is dropped from the helicopter. The man who is weighing 70 kgs holds to the inflated tube of this mass. Okay. Or the helicopter is flying horizontally at a constant speed. So constant speed, zero acceleration. The average frictional force they gave us to us, the surface of the water helicopter, then the rope makes 50 degrees to the surface of the water as shown. They want us to state Newton's first law of motion. So we know that this law simply tells us that an object will remain in its state of rest or uniform motion unless acted upon by an external force. Or sometimes we say the external force is a resultant force, okay? So an object or a body will continue in its state of uniform motion or rest unless acted upon by a net force. Then 3.2, they want us to draw the free body diagram of the man-tube combination while they're being dragged. So 4 marks, those are literally 4 forces. So since there is friction, which means the frictional force is going to act in that direction, there's going to be the normal force of the combination, the weight, and then we're going to have that tension. Okay, so Fk in that direction, this is going to be the Fg for the weight, this is Fn, and then let me just put it at an angle. I don't want the component. I'll say that is the tension force. Then they want us to calculate the tension within the rope. Tension within the rope. So if I resolve this, I'm going to focus on just the horizontal component. So that's going to be T cos of 50. So from my F net is equal to MA. I'll have the T cos of 50 minus my frictional force. It must give me this, but we know that the acceleration is a 0 since the speed is constant. So T cos of 50 minus the frictional force, which was 300, it must be equal to 0. Let's move the 300 that side. So tension is going to be 300 over the cos of 50. So punching that in the calculator, I'm getting 466.72 newtons. So that's what I'm getting. For people that attempted this paper, just tell us, how did you approach this question? Because this is what I'm ending up with, 466.72 newtons. All right, then 3.4, how will the answer in 3.3 change if the helicopter accelerates while dragging the man? Okay, the frictional force and then the angle between the rope and the surface of the water will remain the same. Okay, so the issue is the helicopter is accelerating. So how does that affect? How will the answer in 3.3? So in other words, how will the tension change if there is acceleration? So the tension definitely is going to increase. Okay. And what will be the explanation is that as the plane accelerates, there is an additional force. Okay. So there's an additional force that is needed to overcome the inertia state that this is having, because initially it was moving at a constant speed. So for us to change it from being a constant speed into some bit of acceleration, we need to overcome the inertia. Okay, to overcome the inertia. That's the spelling of inertia. Okay, yeah. Okay, to overcome the inertia and give the combination some bit of acceleration. Combination and acceleration. So just some sort of explanation of that nature. Okay, it will increase because you need an additional force to overcome the inertia within the man-tube combination. That's giving it some bit of acceleration. Then 3.5, the angle between the rope and the surface is now decreased to 35. How will the magnitude of the frictional force be affected. Now, remember, frictional force is not dependent on this angle. It's basically the tension force that is dependent on that angle or the acceleration thereof. So is it going to be larger, less than, or equal to? So I'm going for equal to 300 meters. So it's not going to change. And then they want us to give a reason why. Okay, so we know that frictional force is dependent or depends on the surface. Okay, the surfaces of motion, the surface of the object and the water. Okay? The surface between the object as well as the water. That is what is going to affect the frictional force. Other than that, it will stay the same. All right, then question number 4. Okay, I think with this question there was an error. This is the drawing. Okay, let's get that question. Telling us there is some 8-kilogram block on a rough surface connected to a 2 kg, connected by a string passing over a pulley. The 8 kg moves at a constant speed when the pulley, or when it is pulled by this force. And then the frictional force is 10. They want us to state Newton's second law. So this is the drawing as per the description. And so we know that with Newton's second law, we know that the net force that is acting on a body, or we can say that a net force acting on a body is directly proportional to the acceleration of the body and inversely proportional to the mass. Alternatively, somebody could say that the acceleration on a body will be in the direction of the net force. And then that force, you tell us about the directly proportional and then the inversely proportional to what. So that is how you state it. It's within your books. 4.2, can we draw a labeled free body diagram of the 8 kg? So looking at the 8 kg, we can see there's this force applied. There's this tension. We're going to have the normal force. We're going to have the weight. And then we're going to have the Fk, which is the frictional force. So the free body is going to be Fa. This is Fw or Fg. This is Fn. We're going to have the tension. We're going to have the friction. So 5 forces for 5 marks. Then they want us to get the tension within the string for 3 marks. So we're still basing on the fact that the body is moving at a constant speed. So if that is the case, how many marks is it? It's 3 marks. Okay. So if it is 3 marks, we know that F net is going to be equal to ma, constant speed, that's going to be 0. Then we know that the force applied minus the frictional force minus the tension should give us the ma. So this is going to be 29,6 minus the frictional force. They told us that it is 10 newtons. Minus the tension is equal to 0. Move the tension that side. So tension becomes 19,6. Alternatively, you can look at this 2-kilogram body. Since it's moving in that direction, so it's going to be T, this is going to be the weight. So still use the same thing. F net is equal to ma. So tension minus the weight should give us a 0. So tension is the weight, which is 2 times 9,8. which still gives us 19.6 newtons. All right. And then the 29.6 is replaced with the 50 newtons. Can we apply Newton's second law to each of the block and calculate the magnitude of the acceleration? So what I'm going to do is for the 8 kilogram, okay, this is now a 50 newtons. So I'll just apply the same thing and then see. So it's going to be the force applied minus the frictional force minus the tension is equal to MA. Remember, it's F net is equal to MA. Then this is going to be 50 minus the frictional force, which is still a 10, minus the tension, which I don't know, should give me 8A. Let me make T the subject. I can move it that side, which means T is going to be 50 minus that, which is a 40, move the 8. So I'll call that equation number 1. Then for the 2 kg, okay, for the 2 kg, the tension is still bigger. So F net is equal to MA. So tension minus the weight, which is 2 times 9.8, should give me 2A. Move the T that side, which is going to be 19.6 plus 2A. Let me call that my equation number 2. Then I'll equate the 2 equations. So 40 minus 8A is equal to 19.6 plus 2A. Let's transpose that. So 40 minus 19, I'm getting 19.6. I end up with 20.4. That is going to be 10A. Divide both sides by 10, which means it's 2.04 meters per second squared. Okay, so that is our acceleration. And then 4.4.2, they want us to get the tension. So we can just use one of the 2 equations. Okay, so 19.6 plus 2 times 2.04. All right, 2 times 2.04, that gives me 23.68. That is newtons. So that is 4.4.2, the other one is 4.4.1. Okay, so that would have been question number 4. Question number 5. Halley's Comet, which is approximate mass of this March, was this distance from the Earth at its closest point during the last sighting in 1986. They want us to state Newton's law of universal gravitation. So what we need to know about this law is that every object in the universe, okay, every object in the universe will experience a force of attraction or repulsion, okay? And then that force is directly proportional to the product of the magnitude of the forces. Did I say magnitude of forces? No. The force is directly proportional to the product of the masses and inversely proportional to the square of the distance apart or between them. Every object in the universe will experience a force of attraction or repulsion that is directly proportional to the product of the masses and then inversely proportional to the square. This is a G. All right, so that is that. Then 5.2. Is the magnitude of the gravitational force experienced by the comet greater than, equal to, or less than the gravitational force experienced by the Earth? So in this case, if we have 2 objects, the 2 objects will experience the same amount of forces, but just in the opposite direction. So this is equal to. Then 5.3, does the acceleration of the comet increase, decrease, or remain the same? So we know that force, okay, like from F net is equal to MA. Okay, and we know that the force is directly proportional to the acceleration. So at the closest point, which means the distance decreased. So if the distance decreases, okay, if the distance decreases, it simply means that the force is going to increase. And we said force is directly proportional to the acceleration. So this should be an increase. Okay, so we're saying it's an increase because the acceleration is directly proportional to F. And F is inversely proportional to 1 over r squared. All right, then 5.4, they want us to get the magnitude of the gravitational force exerted by the Earth on the comet at the point when they are closest to each other. So since they want the force, just use this formula. We know that the G, guys, what is the G value? That is 6,67. Okay. So we're gonna say it is 6,67 times 10 to the negative 11. They gave us the mass, which is 1 times 10 to the 15. The mass of the Earth, we can get it from the formula page. Okay, so mass of the Earth, where are you? 5,98. Okay, that is 5,98 times 10 to the 24 divided by the distance of separation. This one, we change it to meters. Kilometers to meters, you multiply by 1,000, which means it's gonna be 1,3. Let's use this. So 1,3 times 10 to the 11 squared. So when I punch this into the calculator, will that make sense though? Was this much from the Earth? From the Earth. So you can use that. Alternatively, you can even add, what is it called? The radius of the Earth. I think that would make much more sense. Because remember, it has to be from the center. This is 6,38. 6,38. So let me just add this, the radius. Okay, so we said plus 6,38 times 10 to the, is it 14? It's 8. It's a 6, 10 to the 6. Okay, and then when you square that, I'm getting something like 2,36 times 10 to the 7 newtons. All right, so that is question number 5. Then question number 6, they're telling us a charged sphere at the end of a wooden handle has a mass of 40 grams. Okay, and carries a charge of positive 20 nanocoulomb. A learner brings the sphere close to a tissue paper of 0.5 grams and then charge of negative 1 nanocoulomb. The force between the tissue and the sphere is that. Can we give a reason why the sphere is attracted? No. Why is it attached at the end of the wooden handle? So this happens so that we can preserve the charge. Okay, alternatively, we can say we need to avoid the loss of charge or charge loss. Then which object between the sphere and the tissue paper has excess electrons? Now this one is positively charged, which means it has excess of protons or positively charged. And then this one is a negative 1 nanocoulomb. So in this case, it's just gonna be the tissue paper. Tissue paper has more electrons. Then 6.3, the sphere and the tissue paper are made to be in contact for some time, then they are separated. They want us to get the charge after they've been in contact. So it's a Q1 and Q2 divided by 2. Okay, 6.3.1, we're saying get a positive 20 nanocoulomb plus a negative 1 nanocoulomb, then divide by 2. So 19 nanocoulomb divided by 2, which gives me 9.5 nanocoulomb positive. Then 6.3.2, they want the number of electrons that were transferred between the tissue paper and that. So what we can see is that initially it was -1. Now it is this. So which means the amount of charge transferred was 9.5 minus -1, which becomes 10.5 nanocoulomb. So this is our key. We're looking for the N, but we know that the E is 1.6 times 10 to the -19. That's the electron charge. Then let's use the formula that has this. So it's going to be 10.5 times 10 to the -9, 1.6 times 10 to the -19. So punching this into the calculator, I'm getting 6.56 times 10 to the 10 electrons. All right, then 6.4, telling us that we have 3-point charges. R, S, T shown below. Point T has -6 nanocoulomb. R has 11 nanocoulomb, and then this is a 5 nanocoulomb. Calculate the magnitude of the net force that is acting due to the presence of R and S. So we need to get the force between this and then the force on T as a result of R. So for this first one, I'll say FTS. We know that it is K Q1 Q2 over R squared. Our K is 9 times 10 to the 9. The Q1 is 6 times 10 to the -9. The Q2 is 5 times 10 to the -9. Distance, change this to meters to, sorry, change the centimeters to meters, which is 0.02 squared. Punching this into the calculator, I'm going to end up with 6.75 times 10 to the -4 newtons. Okay, but then this is going to be acting downwards since there's some bit of attraction because of opposite forces. Is it attraction or repulsion? This and then that. All right, then when I look for the force TR, it's just going to be the same process. So 9 times 10 to the 9 times the 6 times 10 to the -9 times 11 times 10 to the -9 over 0.025 squared. Punching that into the calculator, I'm getting 9.5 times 10 to the -4 newtons, but this is going to be to the left since there's still attraction. So this will be upwards, I think, and then this will be to the left. Then, so I have this as my horizontal, I have that as my vertical. Then I have to use the Pythagoras. So for me to get my F resultant, it will be the F vertical squared plus the F horizontal squared under the square root. So that's going to be, the vertical is 6.75 times 10 to the -4 squared. This is going to be 9.5 times 10 to the -4 squared. Everything is under the root sign. So what I end up with is just 11.65 times 10 to the -3 newtons. Then since force is a vector quantity, I can also get the angle, which is the upturn of the vertical over the horizontal force. So when I replace the vertical and the horizontal, I'm getting just a 35 degrees or 35.39. All right, so that is question number 6. Question 7. Question number 7, telling us that a positively charged ball A hangs from a string. Then there's a non-conducting ball that is brought near the neutral ball A. Ball A is seen to be attracted to B. Can we give a reason why B will be attracted to ball A? So the question says A is seen to be attracted to B. Now, why is B attracted to A? Okay, regardless of which one is attracting the other. But now, for as long as we have a neutral body and then a positively charged, this question seems to be mixing up things. Okay, so but in reality, there is going to be what we call is going to be induced charges. Okay, in other words, there's going to be a negative charge that will be induced closer to A, and then this negative induced charge will cause there be some sort of attraction. So we say in the presence of induced negative charge on B, or comes on the side of B closer to A. That is closest to A. So that's the reason why there is that sort of attraction. Then 7.2, they want us to state Coulomb's law in words. So we know that Coulomb's law simply states that, what does it state? That the electrostatic force between point charges is directly proportional to the product of the magnitude of the charges, but inversely proportional to the square of the distance between them. Then they want us to sketch the graph showing the relationship between the electrostatic force and then the charge. So we said F is K Q1 Q2 over R squared, which means if we are to draw the graph, this is going to be the charge in coulombs. This is the force in newtons. So it has to be just a straight line to show that force is directly proportional to the charge. You increase the charge, the force increases. You decrease it, opposite is true. All right, then 7.4. The diagram below shows a small sphere X from which 938 electrons were moved. And then we have 2 points A and B at different distances. So what is the nature of the charge on X? Choose positive or negative. Now, since we have removed 938 electrons, then whatever will be left will be more positive. Okay, so I'm going for positive since electrons were removed. It's not like they were sharing or transfer them equally. Then 7.4.2, they want us to calculate the charge on X. So I think we can use this. Q is equal to NA, NE. So we have 938 multiplied by the 1,6 times 10 to the negative 19. Okay, so when I punch that into our calculators, 938 times 1,6, negative 19, I'm getting 1,5 times 10 to the negative 16 coulombs. So that is the charge. And then 7.4.3, they want us to define electric field at a point. So we know that electric field at a point is basically the force per unit area or per unit charge that a small positive charge that is placed at that point would experience. In other words, it's the force per unit area that a unit positive charge experiences when it is placed at that particular point. Then 7.4.4, they want us to draw the electric field pattern that is around sphere X. Now, since we say sphere X is positively charged, if the sphere is having a positive charge, the field lines should be seen just moving out. just like that. Then 7.4.5. At A and B, the magnitude of electric field, which one is greater? At what point between A and B is the magnitude of the electric field greater? So we know that E is KQ over R squared. Okay, that's what we need to know, or that's what we need to remember. But this electric field is inversely proportional to the distance of separation. In other words, if the radius is smaller, or if the distance between them is smaller, then the field is going to be stronger. So the electric field will be greater. So at what point between A and B? So looking at the drawing, you can see that the distance between B and X is bigger than this. So the correct option is going to be A. Okay, so it's saying it's A. The reason, E is inversely proportional to 1 over R squared. E is inversely proportional to 1 over R squared. Then 7.4.6, they're telling us that the negative charge Y of this magnitude is placed at B, and then this one is placed at A. Calculate the net electric field of sphere X. So if I look at, let me just put it aside. If that is our X, that's 0.03. This is 0.01. Okay, so that is a 3.2 and a 2.8. 3.2. This is a 2.8 negative. All right, so let's see. So we're saying the E of X as a result of A is KQ over R squared. So 9 times 10 to the 9 multiplied by 3.2 times 10 to the negative 16 over 0.01 squared. So if this is a positive charge, it's going to be some bit of repulsion. Okay, punching that into the calculator from using the 3-point, that's going to give me 0.0288. That's going to be more like to the right. Then if I look at the other one, is it left or right? It's repulsion, it's repulsion. So it's going to be left. Let's hope, guys, I placed those forces correctly, because this is placed at A. Where is A? A is on the left. Okay, yeah, makes sense. Then let's look for the one at B. So it is KQ over R squared, 9 times 10 to the 9, multiplied by 2.8 times 10 to the negative 16 over 0.03 squared. So that is giving me 0.0028. This is Newton per Coulomb. But this is going to be, is it to the left or to the right? Remember we said here, it's going to be, looking at the force here, this is going to be to the right, because we're focusing on the X. And then this is going to be to the left, since there is attraction. So then the net is going to be 0.0288 minus 0.0028. Subtraction that, I'll get 0.026 Newton per Coulomb. Oh, and write it as 2.6 times 10 to the negative 2 Newton per Coulomb. All right, so that is how question 7 would have been approached. Question 8. Okay. With question 8, they're telling us that we have 3 resistors, the 3 ohm, 4 ohm, and the 6 ohm, as well as a bulb that's connected in the circuit as shown. So initially, all the switches S1, S2, and S3 open. The internal resistance may be ignored. Can we state Ohm's law? So we know that Ohm's law is V is equal to IR. So the potential difference across a conductor is directly proportional to the current across the conductor at a constant temperature. We're saying the potential difference is directly proportional to the current at a constant temperature. So S1 is now closed. Voltmeter and ammeter readings are recorded. Voltmeter and ammeter readings will be recorded when S2 is closed and recorded when S3 is also closed. They give us the table of results. Then they're asking us to explain why there's an increase in the ammeter reading as more switches are closed. Now, one thing we need to know is that when the resistors are in parallel, okay, the effective resistance of this parallel combination, the overall resistor or resistance we get out of all these three, must be smaller than the smallest. So the smallest is a 3. So which means our effective resistance should be less than 3. And if it is less than 3, which means the resistance here has decreased. And if there is less resistance, which means there is more current. Okay. So we can say that decrease in the resistance across the switches will increase the current. Or from Ohm's law, you can tell us that current is indirectly proportional to resistance. You decrease the resistance, current will increase. Then 8.3, they want us to calculate, calculate the resistance of the bulb. Calculate the resistance of the bulb. All right, so for me to get the resistance of the bulb, how many marks is this question? It's 3 marks. So I can use any, because we know that the voltmeter is just connected across the bulb. Okay. So it means we have more current when we have this reading. So R is going to be V over I. Voltage is 7,2 over 3,6, which is 2 ohms. Whichever one you use, depending on the switch, still get the same answer. Then they want us to get the potential difference of the battery. Potential difference of the battery. So remember we're saying the bulb is having 2 ohms. All right. Potential difference. We know that the potential difference is current multiplied by the resistance. Okay. So we can start by getting the voltage that is across the bulb. We already have it as a 7,2. Okay. But remember, this bulb is a resistor on its own, which resistor is connected in series with this parallel combination. So when resistors are connected in series, the voltages across will be different. Okay. Now, if I agree that when all the 3 switches are closed, my current reading is going to be 3,6 amps. Let me get the effective resistance of all these 3. So we know that 1 over R should give me 1 over 3 plus 1 over 6 plus 1 over 4. Let me just punch that straight away. Plus 1 over 4 plus 1 over 6. That gives me 3 over 4. and then I have to switch it around. So which means my R effective is going to be 4/3. So I can choose to multiply this by the current, which is 3,6. Okay. So voltage across the parallel is going to be 4/3 multiplied by 3,6, which gives me 4/3, let's say, answer, multiplied by 3,6. That gives us 2,7. Yeah. 4/3 times 3,6. Did we get 3,6 as a current? Yes. I'm getting 4,8 volts. But now we know that this was 7,2. So which means total voltage will be the 4,8 and then the 7,2, which gives us 12 volts, 12 volts. Okay, so that is how that question would have been approached. Then 8.4, how the brightness of the bulb be affected as more switches are closed. So I'll say still increase because there's more current that is flowing, okay? Resistance is decreasing. Okay, so we're going with just decrease. The explanation will be the effective resistance of the circuit decreases, allowing more current. Okay, allowing more current to flow. That's the brightness. So when more current is flowing, there's more brightness. All right, question number 9. The circuit diagram below, R has 5,6 ohms. Is connected together with a switch, ammeter, and high resistance voltmeter at the battery of some unknown internal resistance. There's internal resistance in grade 11. Okay. So a graph below shows the potential difference across the terminals of the battery as function of time. So T1 is when the switch is closed. They want us to what EMF is. So we know that EMF is the maximum potential difference across the terminals of a battery when no current is flowing. We're saying the maximum potential difference across the terminals of a battery when no current is flowing. In other words, when the switch is open, the reading of the voltmeter that we get is what we call the EMF. So write down the value of the EMF. So where the graph starts from, which is 13V. When S is closed, they want us to get the current that is passing through the resistor. Now, after closing the switch, the 10,5 now becomes the external voltage. I'll take it as my external voltage. Okay, because there is a loss as a result of the internal resistance. So for us to get that, we know that there's just one single resistor, which is a 5,6, so it's already in series. So we know that V is equal to IR. The 10,5 is equal to 5,6I. Divide both sides by 5,6 over 5,6, which means that our current is 1,88 amps. Then they want the power dissipated. So power, you can use the IV formula, or you can use that I squared R or V over R, whichever one. So it's going to be 188 multiplied by 5,6. Nope. It's not 5,6 because 5,6 is the resistance. What's the voltage? It's 10,5. Okay, so I'm getting 19,74. Since it is power, it is in watts. Then the internal resistance. Now, the fact that there was a difference between 13 and 10,5, which is like 2,5 volts. This is responsible for the activity within the battery. Okay, so V is equal to IR, the small r. So it's going to be 2,5 is equal to 1,88 times the small r. Divide both sides by 1,88. Surprised. Internal resistance in grade 11. Okay, I'm getting 1,33 ohms. All right, so that is question number 9. Question number 10. There's a coil with 200 windings and then a surface area of 2,8 times 10 to the negative 3 meters squared. Is rotated at a constant speed in a constant magnetic field of 2,5 Tesla. An EMF of 3,5 volts is induced in the coil. Consider the following statements. The magnitude of the induced EMF across the ends of a conductor is directly proportional to the rate of change in magnetic flux. Which law is this? So this is Faraday's law of induced EMF. That is Faraday's law of induced EMF. All right, then 10.2.1, they want us to calculate the change in the magnetic flux if the angle of the coil relative to the magnetic field is from 0 up until 90. So 10.2, we say the change in flux will be given as the B multiplied by the area and then the cos of theta. Okay, so if I look at 0, my flux is going to be the B, which is 2,5, the magnetic field, the area, which was 2,8 times 10 to the negative 3, multiplied by the cos of 0. This gives me 7 times 10 to the negative 3 Weber. And if that is true, if I focus on 19, we know that the cos of 90 is going to be a 0. So 2,5 times 2,8 times 10 to the negative 3 cos of 90. This must give us a 0, which means that the change in the flux is going to be 0 minus that, which is negative 7 times 10 to the negative 3 Weber. Then 10.2.2, they want us to get the time that it takes for the coil to rotate. Now, since we got our change in flux as negative this, we know from the formula of EMF that EMF is negative N over delta T. Okay. What is the question asking for? They want us to get the time. So delta T is going to be negative N, the change in flux over the EMF. Let's do the substitution and we see. So N, they told us we have 200 windings. The change in flux, say negative 7 times 10 to the negative 3 over the induced EMF, which was 35 or 3,5. It's 3,5. Okay. So when I punch that into my calculator, I'm saying 200 times 7 times 10 to the negative 3. All right, we're dividing it by 3,5. That gives me 0,4 seconds. All right, so that is 10.2.2. Then 10.3. 10.3. By what factor will the induced EMF change if the coil with 100 windings is used? So from the formula of EMF, EMF is directly proportional to the induced EMF. EMF is directly proportional to the number of turns. Okay. Now, if the turns are reduced by a half, we divide by 2, even the EMF is going to decrease by 2. By what factor will it change? So it decreases by a factor of 2. So it's 100. You're dividing it by 200, which is a factor of 2. They want us to give a reason for our answer. We know that EMF is directly proportional to the number of turns. All right, guys, so that was what the paper entailed, and that's how I would have approached it. Okay? Please get down to the comment section and then just tell us how you approached some of these questions and your experience overall with this paper. Okay, so we wish you guys the best in your preparation for paper 2. Bye-bye.